So we're back, week 8. This week we're going to start talking about another member of the fossil fuel family. If you remember, we talked about, at least in the introduction of the oil section 2 weeks ago, we talked about coal, oil, and natural gas. We started with oil. There was really kind of a lot to tackle there. It took us 2 weeks. Coal will finish in a week. And then because natural gas, as we'll see in the future, is essentially a byproduct of both of these, we're going to look at that next week. Okay, so coal. What do we know about coal? Well, it's black, and Santa Claus brings it to you if you're bad, or at least that's what we're telling our children these days. But it famously is this rock that burns. So we're going to talk a lot about coal, how we use coal modernly, or in the modern world. But we've been using coal for a couple of different things for a long time. Notably, there's a type of coal used as jewelry, right? If it was in your reading, I'm sure you've already read and done the quiz about jet, which is a very special type of lignite coal. People use it as jewelry from the Neolithic. It was actually really popular in Victorian England, around 1900. But coal as a fuel was not so widely used. Again, the Romans used it, as you've seen in the kind of historical context. But really, we're going to kind of skip to the modern world. I don't want to dig so deep into the history of coal usage. Coal is what we burn for power, and historically has been dominant. Although one of the things that we're going to see is that dominance of coal is kind of decreasing. So here you can see these graphs are a little bit out of date, so but they're still relevant, right? So you can imagine maybe the numbers shift a little bit. You can see this is total world energy consumption by source, and the three big ones over there, and you see this pie chart, are the fossil fuels. So petroleum, coal, natural gas. You'll see nuclear kind of has its own funky, cool little wedge there. We'll talk about nuclear in a couple of weeks. And then there's this green wedge in that pie chart, and that's all of the stuff that we consider renewables. Again, we're going to spend some time kind of going through that. So backing away from kind of global energy, I want to talk a little bit more specifically about U.S. energy. And also, towards the end of this lecture, or to the end of this series of videos, we will start looking at how those trends are changing. But you can see here, this is a pie chart. I love pie charts. I don't know why, but it's just something that I really feel them. I don't know. Maybe it's because I like pie. But you can see here, U.S. power. We're slightly more reliant on nuclear than we see in the kind of global world. Natural gas and coal, the percent of energy that we actually generate from like fluid oil, like from gasoline, is pretty small, but you can see natural gas and coal are dominant. And then there's some other members of our pie as well, and like I said, we're going to go ahead and make sure that we get into those. The story of how coal forms is something that's probably not going to be entirely unfamiliar to you. It shares some similarities with oil, right? And we really beat into our own brains how oil forms. But if you remember, the big difference between the two was the compounds or the organic material that essentially piled up. We talked about fatty acids, palmitic oil, right? These long organic fats that were basically just carbon and hydrogen, and they formed hydrocarbons, which was oil. And then we mentioned how woody material is mostly made out of something called cellulose. And cellulose has a fundamentally different chemical formula. So you can see here's a generic chemical formula for cellulose, C6H10O5, and then repeated N times for all of the different types of cellulose. But this is essentially woody material, right? And when you think about like cordwood, right? We talked about how like a tree is made out of cellulose, but lots of other things are as well, right? Leaves and kind of brushy material, all of that stuff we would generally consider woody, although it's not, like a piece of wood you would put in your fireplace. So this gets into the historical geology a little bit, and we get to kind of go down an interesting pathway. This is an entirely different class that I teach. I do teach a historical geology class. But if you look back into the history of Earth, evolution's a big theme, right? So as kind of we're marching on, life shows up a really long time ago, about 3.6 billion years. It's mostly just single-celled critters for a long time. And even when more complex things evolve, they generally live in the oceans. So about 400 million years ago, we see some things beginning to move from the oceans onto the continents, the first plants, basically like moss and slime and stuff like that. But over time, on the continents, these plants evolve. Vertebrates, things with a backbone like us, we don't move on to the continents for quite a while. So they're kind of sitting there evolving, but again, mostly kind of tiny little plants. But when we get to about 300 million years ago, plants essentially evolve rapidly, and that's when we see the first forests and kind of swamplands on Earth. And all of a sudden, these continents are just inundated with large, woody things, right? Something that we haven't seen before in the fossil record. Again, we know this from paleontological records. We go look at the rocks and see what sorts of fossils are there. So this period of time, generally we call, well, depends on what continent you're on. We split it up here in the United States, but we call that in the geologic time scale the Carboniferous Period. And during the Carboniferous Period, this really was marked by the proliferation of forests. Also at this time, coincidentally, there wasn't a lot of tectonic mountain building. I mean, there was definitely some, but a lot of the continents were relatively flat, if that makes sense. And so as sea level fluctuates, the shoreline can migrate in really far. And so there were lots of kind of low-lying continental land masses that were fairly swampy. Actually, you can see here, this is Middle Pennsylvanian, which is a subdivision of the Carboniferous about 308 million years ago. This is what we would call a Paleo Geographic Reconstruction. And if you look closely, you can see the fairly familiar outline of where some of the states would have been. Also, you can actually see the equator. So remember that plates are moving, right? They're moving at a pretty reasonable clip. So this landmass that we now refer to as North America was much closer to the equator during this time. And you can also see, again, the blue color ramp is depth. There's a huge portion of kind of eastern kind of now what we call the United States, and even out west that was fairly shallow kind of shoreline. And in many cases, these formed basically what we now call coal swamps. One of the most interesting things about this just explosion of land plants is that nothing had yet evolved that was really using cellulose as its primary food source. Nothing could effectively digest all of this plant matter that was forming in these swamps. And so, trees would grow, these big kind of cool trees. Again, we've already seen this, but you can look back. This is a recreation of a Carboniferous forest. Very specific trees. If you guys take note, you can see there's this kind of scaly texture on these trees. You read about that in your reading. But when plants would die, they would fall over, and they would break down a little bit, but nothing would be consuming them. And so more plants would fall, more plants would fall, more plants would fall. And what happened is you just get this thick stacking of organic material in an anoxic environment, meaning it can't further decompose. And because these forests were so prolific and nothing was in there consuming cellulose, these layers got really, really, really thick. And then occasionally, sea level would rise and cover them with sand or silt or some other materials, and so we'd get this layer preserved that was basically just plants, or a really high percentage of plants. We talked about organic flux. So we've talked about organic flux in the context of oil, which was dying plankton and things kind of snowing down out of the water. Here, you have to imagine kind of a swamp and leaves and branches and those sorts of things falling in, as opposed to all of those little planktons. Cellulose rather than fatty acids. And so again, then we get this preserved layer, which is basically just plant material.